Okay, so that completes the lecture. So just to summarize some main lessons we've learned here. There were 3 steps in deriving the language models I've shown you. The first step was to expand the joint probability over any sequence of words, W1, W2, up to Wn, using the chain rule of probabilities. This is what I showed you in the portion of the lecture on Markov processes. And the second step was to make Markov independence assumptions. In particular, assuming that the probability of some word, Wi, conditioned on the entire previous sequence of I-1 previous words, actually depends only on the previous 2 words in the sequence. We call this a second-order Markov assumption. And the final step in deriving these estimates was to smooth these trigram estimates, essentially using low-order accounts. And that was done either through the method of linear interpolation or through this discounting method that I just showed you. So just briefly, language modeling is a huge industry, and there's been a lot of research in improved methods for language modeling. Some areas of particular interest are methods that model the underlying topic of documents or other long-range features of a document. So conditioning on just the previous 2 words is certainly limiting. And in some cases, you might want to condition on the fact that a document is about sports or is about politics or the general topic. That can influence the words that are seen in the document. It might be important to condition on that. Or we might condition on words which are outside this 2-word window. There's been considerable interest in that problem. Another type of model that we'll see later in the class is language models based on syntactic models, language models that explicitly trying to incorporate grammatical information about what sentences are grammatical versus not grammatical in a language. And again, these models can often capture long-range features which fall outside just a 2-word window. Overall, though, it can be quite difficult to improve upon language models. They're simple, they're very efficient, and they can get us a long way in many problems.